Hi! In this patch I made an ARP using step 8 and I'm sending the scan output here to the one of the volt per octave inputs on cycle 5. I want to transpose this ARP with a precise voltage, and to do that I can use the top section of route 4 here. When I patch a gate output of the first stage of step 8 here into one of the control inputs of route 4, the main output here of the top half of route 4 gives me a 1 volt signal. Well, in fact, there's a 1 volt signal normal to all of these outputs when nothing is patched into the routing inputs. I can send this 1 volt into the second volt per octave input on cycle 5. And due to the latching behavior of route 4, which we set with this switch here, we get 1 volt, 1 octave transposition every cycle of step 8. I hope that makes sense. Now I want to transpose it with another octave. What I could do is take a second output of step 8 here, send it to a second control input, and this is already nice, but in fact I want, and while this is nice, I actually want the cycle to play fully before it transposes. Now it transposes a second time in the middle of the sequence. To do this, I send the gate output of step 8 into compare 2. And when I set up compare in such a way that the gate is in the window of only one side, the flip-flop output will give me an alternating signal every time step 8 has done 1 full cycle. So I can use this to send into route 4. I actually need to disengage the second channel here. So now we can see, again due to the latching behavior, that every 2 times step 8 does a cycle, the melody gets transposed. I can do more. I can take the output here of compare 2, which will give me a copy, well, kind of a copy of the gate signal that I'm sending into the first channel. If I send this to a second control input on route 4, and because we have set this switch on route 4 to multi, we get 2 volts that transposes our sequence every few cycles. Let's add some context.